we're going to start then. First off, looking at application to the angle measurements that we were looking at yesterday. So we have a pizza, and we had a discussion first hour. Is there any delivery, not frozen, any delivery pizzas that come square?
No, you can order them square.
Tower? Yeah.
Tower's round.
No, you can order them square.
The entire pizza, not the slices. The entire pizza. Is everything? Kasana's is still circle.
Pizza Hut.
No, you can order them square though.
Yeah, Pizza Hut.
Pizza Hut is square.
Pizza Hut is square.
And Little Caesars, if you get the deep dish, then it's square.
Little Caesar's deep dish is square because the regular is
Yep.
circle, isn't it?
Papa John, you can specify square pizza.
Why?
I think you,
Some people
get
just
more
want square
pizza.
pizza.
Some people don't like
Papa John's
triangles.
is
When you get
good.
the pizza box at Pizza Hut, it
Triangles
comes in
remind me
square.
of my
The rectangle
Yeah.
box and stuff? Okay. Well, for our purposes in here, we're going to pretend that there is no square pizza, okay? So just so we get that clarification out there, that our pizzas are round, okay? Because then it will work with the arc length and the circumference and the area of a circle that we're going to be looking at, okay? So we're just going to make that straight out assumption that all the pizzas that we're looking at in here are going to be circles. All right, so Domino's, they cut their 16-inch pizza into 8 pieces. Now, anytime that is 16-inch, 18-inch, when it's talking about pizza, wheel diameter, anything like that, we're looking at diameter. So what we're saying here is the diameter is 16 inches. Therefore, if the diameter is 16, what is our radius? Okay, I kind of jumped ahead a little bit on that. You'll see why we need that here in just a second. So we want to know how much pizza, aka the area, and crust, circumference, did we get for lunch? How appropriate, because you guys do get Domino's and Papa John's on occasion. Once a week, that would be. So area, refresh my memory. I've already forgotten. What's area of a circle? Area of a circle. Say it with confidence, Brad.
pi r squared.
You got it. Area is pi r squared. What's circumference? I heard somebody over here say
2 pi r.
2 pi r is my circumference. Those two equations, whether you want to highlight that or note that right now, you'll need to know those. Those will not be given, okay? You, at this point in the game, need to know area of a circle plus the circumference of the circle. Can somebody describe for me the difference between finding area versus finding circumference? Mary.
Area is like the whole pizza, and circumference is like just the crust, like the circle around.
Okay, that's perfect. The way she said it, area is the whole pizza, but then when she used to describe circumference, she said that's the crust. It's what goes around it, okay? So circumference to a circle is like perimeter to a square, all right, if you want to look at it like that. Area is just what's on the inside. Area is the sausage and the sauce and the cheese and all that other kind of stuff. Circumference is the crust, okay? So let's calculate the area. Not a difficult problem. If we're looking for the area, we're going to take pi. We already determined the radius to be 8. So pi times 8 squared. When you are doing these problems, use the pi button on your calculator. Do not use 3.14. You'll get a more accurate answer.
201.
0.6.
06.
Okay, 201.06 inches squared. Perfect. All right, now let's do the same thing, locating circumference. 2 times pi, my radius we determined to be 8. Again, using the pi button on your calculator.
50.27.
50.27. Okay, so that's just finding area, finding circumference of a piece of pizza. Actually, this would be the whole pizza. That would be the whole pizza. Okay? So what we're going to do, we just calculated the area inside an entire pizza. We found the circumference the crust length of an entire pizza. What we're going to do now is we're going to transition into finding partial area and partial circumference. We don't call it partial circumference. We don't call it part of the crust. We call it arc length. So, we have a piece of pizza, and you guys can hold back your enthusiasm of my great drawing here. And it's not a piece of Swiss cheese. Okay, so there's my pizza. My pizza will have mushrooms and onions and peppers. I am 100% serious. I would much prefer a veggie pizza over any other. Hawaiian's not bad. Ham and pineapple.
Hawaiian pizza is so good.
Honestly, though, you put any pizza in front of me, it'll be gone. I'm not picky. Okay, so what?
Anchovies.
Okay, that. Why do we even offer that? I mean, seriously.
For this argument.
For this argument, absolutely. Okay, so there's my piece of pizza.
I've never had these.
If I'm looking for arc length, I am looking for just the length of the crust of a slice of pizza. I'm looking for just this right here. It's called arc because it's not a straight line. If it's a nice pizza, it's got a nice little curvature to that crust. Okay, it doesn't have to be a nice pizza, but a typical, I'll use the word typical pizza, has a curvature to its crust. Okay, so that's what I would consider to be the arc length. So in general, to find arc length, you take the angle measurement will be given either in degrees or radians. You're going to take the angle measurement over the entire piece. So to do angle measurement over the whole, so we're assuming we're in degrees. So whatever the angle measurement is over the whole, and then we're going to multiply it by the circumference, which you guys already determined to be 2 pi r. Well, 2 can divide into 360, so I'm left with angle measurement times pi times the radius all over 180 degrees. That is arc length, generally speaking. We're going to find that arc length in degrees, which actually is this, I say generally speaking, but this is in degrees, is going to be just a little bit different than if radians is what's given. So the most difficult part of this is making the distinction between arc length in degrees, and if you just take your eyes down further, arc length in radian measure. Okay, so two different formulas that we're going to be looking at, all deriving from the same basis. So here it is, and again, I'm sure it's because of some French, Greek word that we have arc length represented using the letter S, okay? So arc length is S. So S is going to equal pi times my radius times my angle, all divided by 180. We already discovered that up above. That's where that is. And then here in bold is exactly what we just did. So it starts out with a partial angle over the whole angle times circumference, which is 2 pi r. And then the 2 and the 180, the 2 and the 360 cancel to give us the 180. That's where that comes from. All right, so let's put it to practice. Again, hopefully you're not too hungry because we're continuing talking about food. So we want to find the crust length, arc length of a 45-degree slice of pizza. It's a pretty good chunk. From a 14-inch pizza. It's probably more of a medium-sized pizza. And again, when the size of the pizza is given as it is here, that is my diameter. So what is my radius? All right, so I'm going to use the arc length directly above. If I'm finding the crust length, that means the same thing as finding the arc length. So S equals pi times my radius times my angle measurement, all over 180 degrees. You can type that directly into your calculator using the pi button on your calculator and divide it all by 180. And hopefully you come up with 5.5. And that is what we use to find arc length using degrees. Okay? And that's probably typical when you guys are sitting down to eat your pizza and you say, oh, look, I've got a 30-degree-inch slice of pizza here. I wonder how much crust I'm going to consume because I'm on a very low-carb diet. So the less carbs that I consume, the better. I have to keep my carb, content to be less than 5 inches per slice. So let's figure that out using arc length. My gosh, I just learned that in pre-calc today. Good thing that we discussed that because now I can figure out the crust length of my 30-degree piece of pizza. That's the typical conversation you have in your head when you get a piece of pizza, right? Okay. All right. So any questions on that in degree measurement? All right. For those of you that thought I was a little crazy thinking the 30-degree, well, you guys are probably thinking in terms of radians. That's why you probably didn't think it was too, all that great. So here I go again, arc length, but this time I'm in radian measure. The radian measure, even though it's a little bit not as familiar to us as degree measure, is a much simpler, straightforward equation. So we have arc length equals radius times theta. So arc length, again, is angle over the whole, but instead of 360, if we do a full circle looking in radians, we've actually gone 2 pi radians if we go a full circle. So it's over 2 pi times circumference. And because it's over 2 pi, the 2 pi in the circumference and the 2 pi in the radian measure cancel out. And I'm left with just radius times theta. So here we go. So we want to find the arc length. So that is S of a pi over 9 angle in a circle with radius 4. So arc length equals, so my radius is 4, my angle is pi over 9. 4 times pi over 9. On your calculator, you should get 1.4. Yes. Okay. So now what we've looked at in both of these is like a partial circumference, arc length. Okay, so it's like the outer edge, the crust. What we want to now go, and we're transitioning now to the area. We want to look at the actual, how much am I going to be consuming? Not just the crust, but how much pizza am I going to be consuming? How much area is involved? So now I'm looking at my piece of pizza, and I'm looking at, bless you, the area. Okay? So to find the area, I'm taking my either in radians or degree measurement over the whole. I still have my partial over my whole, partial angle over my whole, but instead of multiplying by circumference, I'm multiplying by area. So the exact same principle's going on, but depending upon if I'm looking for arc length or if I'm looking for area depends upon whether I'm multiplying by circumference or multiplying by the area. And here, my pi's cancel, so I'm left with my angle times r squared all over 2. This is radians. This is degrees. Okay, that is an arrow. It looks really bad, but that is an arrow. So again, partial degrees over whole degrees times area. So let's put this to practice. We want to find the area of a slice of a 16-inch pizza if the central angle is, here we've got one example in radians and one example in degrees. If it's a 16-inch pizza, what is my radius? 8. Perfect. All right. So radians goes first. So I've got 7 pi. So I'm looking for the area. So 7 pi over 9 is my angle measurement. That would be a 12, not a 9. I'm not sure where that came from. 7 pi over 12 times my radius squared. And all of that is divided by 2. And I'm coming from this formula right there for radians. And literally, again, you can take that on your calculator, 7 pi divided by 12, that multiplying by 8 squared, all of that then divided by 2. It's 58.64 units squared, or inches squared. Okay, and again, it's important that you guys are following along, typing this into your calculator to make sure that you are appropriately putting the numbers in. So that's with radian measure. Moving over to degrees. Here's my equivalent for finding area when degrees are given. So area equals 50 over 360 pi times my radius squared. And again, typing that directly in. $27.93. So just a real quick recap. The beginning was circumference, arc length, the piece of the crust, so to speak. The partial circumference of a circle, given in radian measure, given in degree measure. Then this last piece was strictly area, again, of a circle, given an angle measurement. A partial piece of the circle, I should say, finding the area of that piece of the pie, a piece of a pizza, a sector, a specific sector of a circle, finding that area. Okay? Questions on this front page?
It's squared, right? The 27.
Correct. Yeah. Okay, flip to the back. Some of you guys are in a chemistry class, and I think in chemistry it's called dimensional analysis. I like unit analysis. But it's the same thing. And again, we are looking at a unit of measurement, angle measurement, that we are going to convert from one unit to another. And if you follow along knowing that if you set up your units correctly, they cancel out until you get to the unit that you need. That's basically dimensional analysis. So, and the same applies to angular and linear motion, either one. Okay? So, and this just kind of spells that out. Angular is revolutions per minute, and linear is going to go into something similar to like miles per hour. These are examples. So let's look at our example. We've got Jim's truck has 36-inch wheels. Wheels are measured just like a pizza. That would be given the diameter. If the wheels are rotating at 630, RPM is the same thing as revolutions per minute. So that's RPM. We want to find the truck's speed in miles per hour, MPH. Okay, so the first thing I want to do is I know that I am in, the wheels are rotating at 630 RPM. I've got revolutions, and actually I don't want you to write it like that. I want you to write it as revolutions per minute. And I want to end up in what units? Miles per hour. Okay, so I start out with revolutions per minute, and then you always want to keep in mind your goal. I want to end up in miles per hour. If you have learned this in a way that totally 100% makes sense and you've got it, stick with it. Okay, I'm not sure that it'd be all that much different, but maybe the order in which we work things might be a little bit different. But otherwise, kind of stick with how we're explaining and going through it this morning. So I know that the wheels are rotating at 630 RPM. Okay, so I'm just going to know, I know that it's 630 revolutions per 1 minute. And I would go ahead and write it out, not just R over M, but so that you know that you know that you know this is revolutions and this is per minute. Okay, now I want to pause just for a second. That if you have a wheel, and I mark it at a spot right here, okay? And that wheel is moving forward. Now that mark is here, and now the mark's down here. Now the mark's here as it continues to move forward. When it moves up above, if I was measuring that, what did I just find in 1 revolution? It goes from here. I found the circumference. 1 revolution equals circumference. What is circumference of a circle? 2 pi r. Critical. So understanding that if I marked the wheel and it was moving forward, if I measured that, I would have actually found the circumference of that circle, of that wheel. Okay? So 1 revolution is the same thing as circumference. All right? So now, let's go back to our problem that we have set up. I have revolutions per minute. I'm just going to go with revolution. I know that I want to end up in miles per hour, correct? All right, so do I want revolution in my end result? No. So I'm going to multiply this by something that's going to get rid of my revolution. So if I want to get rid of my revolution, is revolution going to go on the top or the bottom? Bottom. All right, so what does 1 revolution equal? 2 pi r. Okay, by putting my 1 revolution in the denominator, revolution, revolution, cancel. Now my r, what is my r? My radius, which is 18. So my radius, I'm going to change this to 18 inches. Okay, I'm going to change my radius to actually say 18 inches. Don't neglect your units, especially on this example, because that's the whole key here, is I want to go from revolutions per minute to miles per hour. Okay, so I've gotten rid of my revolutions. Now let's look at minutes. I'm just sticking with this first fraction, this first proportion here. So I want to go to minutes. I know I want to end up in hours, correct? So I need minutes to be gone. So are minutes going to be in the numerator or denominator? And I want to end up in hours. Can I do a conversion from minutes to hours?
Yeah.
Yes. How many minutes? To 1 hour. Well, look there. My minutes canceled and I'm left with hours. Do I want hours in my final result? I do. So that's going to stay put. I'm not going to touch that. Okay, so I've gotten rid of my revolution and my minutes. Let's move to the next fraction. And I have inches. Do I want inches in my final result? No. But can inches help me get to my final result? Yes. So I have, if inches is in the numerator here, where does it need to go here? In my denominator. What's a good measurement that will help me step me maybe 1 step from inches to where I want to be with miles? What would be a good next step? Feet. So 1 foot is how many inches? Okay, so that inches are gone. Do I want to be left with feet? No, I want to be left with miles. And so I need to get rid of feet. Can I do a conversion from feet to miles? Yes. All right, who knows how many feet are in 1 mile?
5,280.
You got it. 5,280 feet. That is something that you will need to know. Okay? You will need to know that. Feet, cancel. So now I'm left with miles. So are the only two conversions, the only two units left, miles on numerator and hours on top, because that's what I want, miles per hour. Am I there?
Mm-hmm.
Yep. So you pick up your handy dandy calculator, you do all your multiplication, and then you divide by 12 and divide by 5,280.
Wait, so when, like, okay, so, so when you canceled out 12 inches, did you cancel out just the inches, or like,
Only the units are canceled.
so the numbers stay?
Numbers stay.
So do I just multiply across them?
Just multiply here and divide by here. Yep. And you should end up with 67.47 miles per hour. And if you don't get that, double check how you're inputting that into your calculator. So you're going to take 630 times 2 times pi times 18 times 60. And you can do that either way. Then you can do, enter, get a number, and then take 12 times 5,280, get a number, and then divide those two. Or multiply all this, divide by 12, divide by 5,280. So both of these are in the denominator, so they both need to be divided by. Okay? You will have more practice on another one of these in your homework, plus the review sheet's got a couple of them on there as well. And I know, again, like I said, those that have been in chemistry, you've seen situations like this, not probably car driving, but more in your chemicals and that kind of stuff as you work through. Okay, so questions on that? And I can come back to that too at the end if we need to. Okay, so I had mentioned that we're still in measurements, and now we're going and doing a little bit different things that we don't hear about as much. And this is our nautical miles, and then also we're going to do a little bit on navigation. We will be using this area down here at the bottom. We'll be filling all of that in, so be sure to leave appropriate space for that. So a nautical mile is the length of 1 minute, remember degree, minute, seconds, that's what the minute comes from, of arc along Earth's equator. So that just kind of gives you an estimate of what a nautical mile is. And then our statute mile that we know of is about 0.87 nautical miles. Or a nautical mile is about 1.15 statute miles. All right, so we've got a conversion that we have going on here. So if a statute mile is given, so the distance between Boston and San Francisco is 2698 statute miles, we want to know approximately how many nautical miles is this. So we're in statute miles, so we have 2698 miles. We want to get to nautical miles. So we're just going to multiply by 0.87. Because I want to get to nautical miles, so I'm going to take the statute times 0.87, and I will get 2,347. 26 nautical miles. That's just a strict conversion. You could have done your 2698 statute miles is equal to 0.87 times x, solve for x. But setting up your conversion back and forth. Okay. We have down here, I'm going to give you just, this is kind of a boring, but this does come out of your book, and it was omitted on the notes here, so we're going to write this in. What is navigation? So you've got a couple sentences here. Navigation, course or bearing, same thing, of an object is sometimes given as the angle of the line of travel measured, and here's where we're really focusing in, measured clockwise from due north. Okay, so navigation is the course or bearing of an object sometimes is given as the angle of the line of travel measured clockwise from due north. Say what? Okay, we're going to see what that means here in just a second. Let you guys finish writing that down. And then off to the right, I want a small circle, and in the middle, I want a big circle with area to write around it. So there's my big circle. That's not a bad circle for me. And there's a small circle. On the small circle, we're going to draw what we know of as our typical unit circle. Okay? So 0 degrees on a unit circle is located like north, south, east, or west. This is north, this is south, this is east, this is west. Where is 0? Okay? So this is 0 degrees. Then which way do I go? Clock.
But it says go clockwise.
No. Normal, our normal unit circle.
Okay, then you go counterclockwise.
I go counterclockwise, so this is 90 degrees. This is our typical unit circle. In fact, that's what we're doing in Algebra 2 right now. 180, 270, and then I'm back to 360 degrees. Okay, so that's our typical unit circle that you have been playing with. And this is what I mean by that. Okay, so 0, 90, 180, 270. All right, so that's our typical unit circle to be filled in. Now what they're talking about here, how navigation we use, what we're going to do is we're going to set up a compass, so to speak here. So I'm going to first do north, south, east, and west. That might be a little bit easier for us to make our angle measurements on here. North, south, east, and west. And it says that the angle of line of travel measured clockwise from due north. So due north is going to be 0 degrees. Then if I go clockwise, where is 90 at? And continue on. South then becomes 180. West is 270. And then I get back to north, and I've done a full circle at 360. So navigation uses a different degree measurement than what we see in the unit circle. And actually, to me, this makes a little bit more sense. All right, so now let's fill in our unit circle a little bit. Excuse me, our navigation compass. So in between north and east is a direction called what?
Northeast.
Between east and south is a direction called southeast. And in between south and west, southwest. And in between north and west is a direction called northwest. We're going to fill in it even more. There is a direction in between north and northeast called north-northeast. There is a direction in between northeast and east called east-northeast. In between east and southeast, east-southeast. In between south and southeast is south southeast. In between south and southwest, south southwest. In between west and southwest, west southwest. Are we having fun yet? In between west and northwest, west northwest. And in between northwest and northwest. Okay, so here's a question that I could very easily ask you coming next week. What is the degree measurement at northeast? 45 degrees. What is the degree measurement at east northeast? What'd you say? At east northeast. $22.5, but what do I do with that?
Plus 45 and 67.5.
67.5. So we have, you're finding the average between 45 and 90, and then whatever that average is, you can add it to 45 or subtract it from 90 to get to that. So be prepared that a question like that will be a really good question to ask, but it could occur more so on this side of the compass as well. So making sure that you know how to draw your navigational compass on that. Okay? Questions?